This is our, again, first of our webinar series, and it's how, the topic is how SQID proprietors can exaggerate the stormwater treatment performance claims via SQIDEP. Now, the presenter today is none other than Michael Wicks. And Michael is, most people, a lot of people may be familiar with Michael already. I know him vaguely. He's my boss, and I should point out that hopefully I'll still have a job by the end of this if I do a half-decent job of emceeing this. So, but look, I'm environmental engineer at Ocean Protect, but Michael is the technical director and co-founder of Ocean Protect. He's essentially owned and managed the business for over 10 years with his business partner, Jeremy Brown. And look, Michael essentially oversees all the technical direction of the company. So developing, testing and implementing, I guess, solutions in the stormwater quality space. And without further ado, Michael, I might pass it on to you, but just as a reminder, because I know people are essentially progressively coming through. Again, just a reminder, if you have any questions, please put them in the Q&A forum. We will do our best to address them as well as we can. And if you've got any technical difficulties or whatever, just put it in the chat forum, I guess, and I can try and address those as quick as I can. Without further ado, and just as a reminder, Michael's presentation will be about 20 minutes. We'll probably have about 20, 25 minutes for Q&A, but we should be wrapped up essentially by, say, I don't know, 1:50. So without further ado, Michael, I'll pass the reins over to you.
Thanks, Brad, and thanks for the intro. It's quite nice, actually. So, look, guys, today, a little bit of a dry topic, but something that's really been close to my heart for a while, and it's SQIDEP. And basically the title today is how SQID proprietors can exaggerate the performance claims by using SQIDEP. So we'll jump straight in. So we'll delve into a bit of the background on what is SQIDEP, some of the key issues around SQIDEP, and I'll use terms like cherry picking, of data, you know, dissolved inorganic nitrogen. I'll talk about that, and we'll talk about the importance of, you know, water flow and water quality monitoring that's basically mutually inclusive, that has to happen together. And you know, you can ask yourself the question as well, does it really matter? Well, is it appropriate this wheel wall here in this picture on the right gets 80% TSS? Probably not for nitrogen removal, but anyway, and then it's not all doom and gloom today. We'll be talking also about what are some potential solutions and what's happening in this space. So what is SQIDEP? There'll be a few acronyms here, so I do apologise up front. SQIDEP is the Stormwater Quality Improvement Device Evaluation Protocol. It was developed by the SQIDEP Committee, which is the Stormwater Quality Improvement Device Advisory Committee. And that was over a process of about 5 or so years. Mostly made up of manufacturers and a couple of consultants. So yeah, there was a sort of mixed grouping there, but there was limited regulatory involvement. The consultation process, well look, in my opinion, in the context of SQIDEP, that's a quite a subjective term. There was webinars, there was some events held, but effectively to get good consultation, you need to have some good buy-in and some good feedback as well. And I think, you know, testament to, you know, the process that's been undertaken, you can effectively see that with limited regulatory endorsement of the process, that the consultation phase could have been done a lot better. But the question remains, or a question could be asked, look, do we get a more rigorous scientific outcome with SQIDEP? And look, in my opinion, not necessarily. So what are the key issues? What are the issues that we want to highlight here? And I think before we really get into it, something we need to acknowledge here. There's been a whole body of work completed by Stormwater Queensland and also by Stormwater New South Wales. And they've put submissions into Stormwater Australia to discuss some of the issues that I'm going to talk about today. Obviously, Stormwater Queensland sent theirs in March this year, and Stormwater New South Wales was late last year. Those submissions are downloadable from their website, so you can go and grab them. And so this is not just Michael Wicks saying, hey, you know, I'm from Ocean Protect and this is what I think. There's also others who have been writing in this space as well, and the views aren't too dissimilar in some aspects. So what are the key issues? What are we looking at? And this is a table from the SQIDEP manual, the technical manual. And look, for our friends in Queensland, there's a big difference that a word can make, and we all saw that in state planning policy a few years ago. And I'll pull to the just to the right-hand side here, you can see hovering with the cursor there, 15 events. It's missing a key word, that word sequential events. So you want events to go sequentially. There's also on this table no minimum requirement to measure dissolving organic nitrogen. And I suppose the take home there is that we all have to measure TN, the total nitrogen. Effectively, it's far easier to remove particulate-based nitrogen than dissolved nitrogen, dissolving organic nitrogen per se. In relation to other parts, or the bottom of the document here, as you can see the bottom of this table, the minimum performance standards are a little bit wishy-washy. 80% has to meet a minimum criteria, but the other 20% does not. And that introduces noise or junk into the data. And it's probably more emphasised by this next slide here. And again, this 50% at the top of the page, hydrograph coverage, and as we know, engineers, hydrograph is just, flow versus time relationship, but at least 50%. So 51% technically can have a good hydrograph coverage. What about the other 50%? Can have effectively whatever. And that's a real dangerous problem. Again, by not having absolute minimums in some aspects does allow you to put in, say, a storm that had, 10% hydrograph coverage, that was in the rising rim of the hydrograph that's usually really dirty, that gets great percentage reductions, putting that in with all your other data, and that's just going to overestimate your results. So half can be effectively junk data, as I like to call it. So it can really skew the outcome. There's also inconsistencies and also some difficulties associated with some of the terminology there. Monitoring inlet, outlet and bypass well. Not too worried about bypass. We're more worried about internal overflow. So some of the terminology is a bit off there. And also the practicalities of, so rain gauge calibration can be quite difficult because you've got to send it back to the manufacturer. So you can end up with downtime on your field testing of 4 to 6 months to get that equipment calibrated. So there's some real issues there. And I suppose one of the big ones and one of the key ones that I've been talking about for a while, and it's been highlighted elsewhere, is cherry picking the results. And I'm going to run through a couple of examples here. And this first example is just of a test site with a cartridge filter. It's the same site, the same testing regime. I think it's the same authors as well, I'm fairly sure. And I looked at testing a stormwater quality improvement device. So it's snapshot in 2 different periods of time. And you've got the data on the table on the left is from 2015 data, and table on the right is 2018 data. And you expect the table on the right to have more subsequent storms, which is fair enough. But I suppose that the issue there is that there is some data missing. There's also some inconsistency in the results. And to be fair, the results have been correct in 2018, but they're different. And that begs the question, I suppose, when you're looking at SQIDEP, without having 15 sequential events, how do you know all the data's there? You don't. So that's one of the things we sort of wanted to highlight, same site, same technology, different publication dates that's been peer reviewed, but yet some of the data is different. And even with another example here, field scale monitoring study, 26 storms, 2-year period. And look, when you set these things up, you should be looking at about 10 storms per year if you've done it before and you understand the equipment and the hydrology of your site. But look, just 26 storms, quite simply. Now, here's 2 tables here presented on this next slide. One with the full 26 storms and then one with the best 15. Now, under the current process, how do you know that the 15 is the best 15, first 15, last 15? It just says 15. So there's no requirement for them to be sequential. So you can go and remove your zeros, and you can get a whopping 50% increase in your efficiency for nitrogen if that's the one that's hard for you to get. You could do the same for TP, same for TSS. It wouldn't be difficult to do. And whilst it's only moved 9.5 percentage points, that makes a huge difference. And I'll highlight later on, I suppose, the differences that this can make. Also want to highlight a key issue of dissolved inorganic nitrogen and the nitrogen cycle. Look, it's complicated. There is no doubt. It's complicated in stormwater in the environment. It's hard to remove. If you're confused, don't worry. I still am at some stages with it. Look, I think the take home here is really that particulate bound nitrogen is far easier to remove than soluble base nitrogen. And so if we look at, say, just a real, basically a condensed version of the nitrogen cycle, we have organic nitrogen, which is mainly particulate there at the top, particulate phase being TKM. And then we have the dissolved inorganic phase down there. And so basically we can break down some organic matter to ammonia, and then it turns to ammonium in stormwater, goes through an oxidation state to nitrite, and then through a further oxidation to nitrate. Fundamental pathways of removal for these pollutants. Look, ammonium, relatively straightforward with a cation exchange. That's been proven in wastewater and stormwater for several years, and it's a fairly reliable process. However, it's more difficult for nitrate. You need to use anion exchange resins or denitrification, by biological processes within, say, a bioretention system with a wet zone and carbon source. The issues abound with that is that the ion exchange media, the right medium, the good media is expensive, $45,000 a tonne, like tenfold what we're currently seeing for media costs for proprietary filters, or the biological processes take time, and which we don't have because a lot of our storms are short and flashy. So how does that relate to SQIDEP? Is it really that important if you miss this point in the document? Well, look, here's an example of real-world field performance monitoring. It's the same technology, so same filter, same media, they're just running at a different flow rate. The table on the left is 2 times the flow rate of the table on the right. But if we look at the removals for nitrogen, the one that's running it on the right, that's running at half the flow rate effectively, has a higher contact time with the media, effectively has a lower percent reduction. And the influent concentrations are about the same. So you sort of go, what's going on here? It's pretty clear. One of them has a really low dissolved inorganic phase of a portion of nitrogen at 15%. The other one's at 46%. So clearly, again, highlighting the issue here, particulate bound nitrogen, and particular nitrogen, far easier to remove than dissolved inorganic. That's why that requirement needs to be in there. And look, we talk about water quality and flow rate, and they must go hand in hand. And we talked about before about the hydrographs and, relationship of flow versus time and what makes that important. This is just an example of a filter that's tested in the United States to their New Jersey Corporation of Advanced Technology, their protocol over there. Just simply done the lab by a company called Climate LLC over there. And we look at some of the information from the report. It was available from that link on the previous slide. And effectively what we can see is that, and when we talk about flow rate, we talk about these different, I suppose, terminologies. Maximum flow rate, this one's got filterable flow rate, and also treatment flow rate. And what happened with the test here is that they tested it 2.5 litres a second, but then they reduced the target flow rate to less than half to increase the efficiency. And this is the importance of having these minimum standards when we talk about hydrograph coverage and 50%. What this is effectively saying is that, the other 50% of your junk storms, your junk data, can have, you can look at monitoring whatever flow rate you want. So you can really boost your performance by putting that junk data in there and playing with the flow rate and efficiency. Because you can see, you reduce the flow rate, typically the efficiency goes up. And 19% is a fair sort of increase. And then there's another key issue is the governance, the verification and governance scheme. Look, in my opinion, it's all but missing. For me, a few pages on the website and a couple of pages here or there doesn't really hit the mark. And conflicts of interest and the declaration of conflicts of interest is, it's a difficult issue. You know, as manufacturers, it's pretty clear that, you know, we have conflicts of interest. Hey, I'm Michael, I work for Ocean Protect. You'll view, I suppose, my comments, questions in relation to that I work for Ocean Protect. However, with consulting engineers and some consulting engineers, it's hard to tell if they have a conflict of interest. So, especially if they've, you know, worked for manufacturers or worked for the same manufacturer, and if they've provided advice in relation to field monitoring, and then if they, you know, haven't disclosed if they've done the work in relation to SQIDEP and things like that, you know, it's quite difficult to see. And as far as I'm aware, there hasn't been any conflicts of interest declaration that's been forwarded in writing, which, look, you guys as the audience and the general industry need to see to make an informed opinion. There's also been, you know, if we look at the validation framework, there needs to be a scoring or weighting system. These are field studies. Nothing is ever perfect. Things go wrong. Get computers to work in the rain. You have some problems generally. So there needs to be some sort of scoring and weighting system. If you do miss a point, how critical is it to the overall outcome? Another good thing that they have in Washington State Department of Ecology is disclosure of applications from manufacturers to their competitors. We're at, you know, the edge of the science here on this. We run a few field sites. Our procedures and practices since when we started, and we did this originally back in 2005, has changed significantly. And your manufacturers, your competitors will keep you honest. So if you know your data has to go to your competitors as well as the body that's going to approve it, you know, there's nothing to hide. There's nowhere to hide. You know, holes and gaps will get found out. There needs to be a thorough grievance process as well. It goes hand in hand with a weighting and scoring system. So if you're not happy with the outcome, there's actually a bit more of a black and white process, I suppose, that you can go through. There also need to be verification statements. You know, they need to consist of things like hydraulics, you know, driving head, appropriate flow rates and the efficiencies, and how you use this to size the technology in music, and then also what you do for maintenance as well. So there's a few things you need to do there, and then also the grandfathering clause. This is quite important, because how do we move through approvals from, say, SQIDEP version 1.3 to version 2? Does your approval last for 5 hours, 5 days, 5 years under 1.3 when version 2 comes in? You know, how long does it last? Because commercially, you'll have technologies that are competing in the marketplace against different standards. And there's been no insight on how that actually works. So, how does SQID proprietors, if they want, exaggerate performance claims via SQIDEP? It's the low bar, people. Just jump over the low bar. The best way, sit out there, get a heap of data, few sites, heap of storms, pick your best 15 storms. That'll give you a fantastic result. One small word makes a huge difference to the outcome. You know, pick non-sequential events. You want sequential events. You want to see what it's like, the performance of the device over time, not just your best events. Go and sample sites with low dissolving event nitrogen. Everyone can go and do some baseline testing, and it's fundamental to field testing to do your baseline testing first. It's relatively inexpensive with disposable sample bottles these days. So yeah, pick a site with no DIM. Just go and do it. There's low sites out there. We showed an example of a filter and one of our sites with 15%, so it's achievable. And you can really exploit the lack of the minimum standards, especially around that hydrograph coverage and the flow rates and the water quality, and adding junk data to the noise and really, you know, lifting your result. Another way is just to get the verification now. Go to SQIDEP, get a verification. Because once you get that verification, no one knows how long it will last. So you could have it indefinitely, go for 2 years. Everyone else who comes along in the background might have to, you know, get an accreditation to a higher standard. So there are ways you can exaggerate it and do it right now. Does it really matter? We'll look at does. You know, if we just look at the sizing and commercial point of view, I've just, you know, we ran out a simple music model here, about 6,000 to 7,000 square metres site with a little bit of bypass, and we just looked at, you know, rainwater tanks, pit basket, cartridge filter. You can see on the graph here, You know, if we just plug 45% removal efficiency into the cartridge filter, we need 100 filters. But we just move that 10 percentage points to 55% removal. We end up having 1/10 of the cartridges in the system. So we go from a large system to a small system. Now, some people might say, who really cares? Well, when your device looks like this and you've got an accelerated maintenance regime because it physically cannot handle the load coming in, it's a problem. You know, we don't want to be on cleaning these devices out. I'm talking about tertiary filters every couple of months. You just don't want to be doing it. So, you know, the performance metrics and the approvals that we get actually affect the sizing and the maintenance of the system and other sizing of the system, no doubt. But does it really matter from an environmental standpoint? Do we really care? You know, we're trying to take, in this case, a high flow bioretention system. We're then looking at, you know, plugging in a technical standard to test it too. We're buying all this fancy scientific equipment, computers that effectively work in the rain when they want to. And then we're getting some sort of accreditation and validation and plugging that into music. All to just, you know, negate the negative impacts of stormwater pollution on our environment. If you're happy with the 3 photos and on the right hand side, then well, who cares? But me, for one, I'm certainly not. You know, we know the impacts of stormwater pollution. We know it as a degradation on our ecosystems and downstream waterways, and we know we have to mitigate them from getting to the environment. Where to from here? So look, not all doom and gloom. You know, there's no point coming with a whole heap of problems and no answers or solutions. And as I said before, look, there's other people working in this space. Stormwater Queensland, Stormwater New South Wales, your peak industry bodies are actually aware of some of these issues and written submissions. There's also effectively a working group that has Stormwater Queensland, Stormwater New South Wales, Stormwater Victoria, Healthy Land and Water in Queensland, Melbourne Water, you know, Water New South Wales, and some regulators trying to advocate change with Stormwater Australia in this space. You know, I think meetings have been requested, but I don't believe there's any meeting as yet. So there is people in this space. So don't be too, you know, it's a concerning issue. Yeah, sure, we need to make change, but there is things happening. But what about the here and now? Like our friend Donald, what do we do? I've got this problem now. How do I solve this problem here and now? I've got manufacturers on my door and they want to get an approval. What do I do? How do I help fix this problem? Look, the first thing I can say for the regulators is, look, don't drink the Kool-Aid. Look, honestly, you know, if you want, ask for the data. You know, the published papers are one thing. The detail is all in the individual storm reports, sequence logs, you know, chain of custody of sampling, you know, your lab analysis reports. All the detail for all your storms is in that. That's the information you should be requesting, not the glossy paper, but all the nitty-gritty in the back end. And you should be asking for the data that, you know, effectively, that, you know, without distribution restrictions. You know, and we're happy for our data to go to other manufacturers, because at the end of the day, you can then have some certainty that, you know, there's a level of rigor in the science. You know, we have nothing to hide. And you should ask for a conflicts of interest declaration as well. You need to view the information in light if anyone has a conflict, and then take their comments or questions in that context. You as the reviewer needs to make that decision yourself. What else can we do? The interim solution may be for you is just a follow-up program that exists. Look, Blacktown Council has a great program. Is it perfect? No. You know, do I agree with all the points of it? No, I don't. But it's a good solution. These guys have got the data crawled all over it. They also have used in MusicLink. So all the treatment manufacturers' nodes are sitting there in MusicLink, which you can download off the website. So they've asked a lot of questions. It's a reasonably good process, and the data's there for everyone to see. So that's a sort of short interim fix that we could put in without requesting additional information, but you can, you know, help solve this problem for yourselves. Now, in a shorter period of time. Do we need to move to a national standard? Absolutely. Would it be easier for us to just meet one standard for the whole country and get endorsement? Yes. I'd love to test to one standard because it means that, you know, it's quite simple for us to do. But when that standard is at such a low bar, in my opinion, that creates some issues. So that's it from me. Brad, if you want to open up, I guess, to any questions, but look, thanks again for tuning in for the first webinar. Hope it's gone well.
No, look, thank you very much, Michael. And you're bang on time. Apologies for my barking dogs in the background. But we've had a couple of questions. Probably the first one was actually from Andrew King, who I think is president of Stormwater South Australia. So welcome, Andrew. Can you see that question, Michael? You might want to repeat it for people who actually can't see the question. Can you see that question okay, Michael?
No, I can't actually, Brad.
Look, I'll just read the question out for you. So Andrew asks, what is your understanding of why SQIDEP calls for 15 storms and not consecutive, as you suggest, is better? If there was not believed to be a valid reason for the non-consecutive decision, wouldn't they have been happy to take this on? Wouldn't they be happy to take on this alternative approach? So essentially, why hasn't Stormwater Australia adopted the consecutive storm requirements as you've suggested?
Look, I don't know. Honestly, I can't speak for how Stormwater Australia has made some of the decisions. That's probably more a question for them. But you know, it's a fairly easy thing to look at. It's something that, you know, at the end of the day, you know, we always get, this is stormwater, remember. This is, you know, we get low concentrations, high concentrations, low flows, high flows. You know, if it was like wastewater, was a constant magnitude of pollutants, a constant flow, we could tailor a solution quite easily. But because we can't, you know, and it's stormwater, there's lots of pollutants floating around, we do get negative results. That's just a part and parcel of stormwater monitoring. But, you know, to then just sit there and go, well, look, we're going to sanitize the data and just pick a number. You know, that's fine, but there needs to be some sequential events around it. From our research, you start to see the trends after probably about 7 or 8 storms is when you start to see the trends. And look, whether it's 15, 12, 10, 20, there's companies and organisations in the States have done reviews, I guess, of all the different protocols. And so all that stuff, you can debate it however long you want, but, you know, 15 there or thereabouts is not a bad number, but the sequential events is a really key issue.
Cool. There's another question from Ainsley Kirk. Question for you, Michael. Has Ocean Protect run their products through the SQIDEP, and how do the performance numbers compare versus your current data? Do you get improvements in performance in line with your assertion that cherry picking of data could result in boosted performance figures?
Look, those examples with the nitrogen was from some of our data. Like, so yes, we can get great reductions. That 26 to 15, you know, we're boosting nitrogen by 20%. So yeah, you run it through the tables, you look at the data, yeah, you get significant change, you get significant boost in performance. And as I said, later on in the slides, you know, even moving, say, nitrogen from 45 to 55% reduction, the filter, it's huge. It makes a huge difference to the size of the technology. So yeah, we've done it, the examples are there, and you can all see that you can reduce your system sizes significantly. And is it more than actually what we play at the moment? Yeah, it is, sure.
Yeah. There's a question from Katie Fletcher from Arup. Hello, Katie. Katie asks, what are your thoughts on testing requirements for other assets, including bioretention?
Look, there is movement in this space. I think there needs to be more testing on bioretention to get a good baseline. I think that when we're looking at our high flow rate bioretention filtera, there's just not much data around. So I think that, yeah, we do need to test some bioretention systems, and there needs to be some appropriate checks and balances there, especially with the vegetative systems, because it's so much more complicated than a cartridge filter. You sometimes have mulch layers, you have seasonal variation, different plants, different blends of media, limited QA checks on the media, all those things. Like, you know, and this life cycle of the plant, all those things, antecedent conditions, climate, all affect the performance. So yeah, I think certainly getting more variation in performance, I would expect in the vegetative systems. And from our perspective, with testing our Filterra and our cartridge fills, that's what we've seen, no doubt. So there should be more testing, absolutely.
And that's actually Katie's second question. She asks, how does Filterra bioretention, which is the high flow rate bioretention systems, how does Filterra bioretention fit between SQIDs and non-proprietary assets? You know, is it a proprietary asset or is it bioretention? Should it go through SQIDEP, etc.?
Yeah, look, tough one. It's basically high flow bioretention. We make a specific media blend, so it is effectively just bioretention running at a higher flow rate. With the appropriate checks and balances that should be done for bioretention media. You know, we have 25, 26 QA checkpoints when we make a batch. We probably should be more checking and testing with making bioretention. So, in my personal opinion, it's closer to normal bioretention than what is a proprietary product. But, you know, who knows where we'll have to run through the SQIDEP process. But we're testing it anyway because we need the data.
Mm. Another question is about whether SQIDEP is essentially just close enough, good enough. Might not be perfect, but is it good enough? Is it a good enough first pass, and can these issues not just be addressed in subsequent versions?
Yeah, look, they could be addressed in subsequent versions, but how do you manage the approvals commercially in the marketplace from one version to another? You can't have a low bar and a high bar and then say, okay, guys, everyone go and compete commercially. That doesn't work. Is it good enough? I don't think the things that we're asking for, we're not asking for gold plating. We're certainly not doing that. What we're asking for is a more consistent protocol. We're just saying, hey, look, here's some massive loopholes here. Just get them out, get rid of them. You know, we're not saying, hey, being overly onerous on requesting sequential events. You know, if it was a massive issue with 15 events being sequential, we'll drop it to 12 sequential events and still have the statistical analysis that needs to go with it. It's not, we're not asking for gold plating, we're just asking for consistent outcomes across the board. But that's probably the key message for it.
Cool. I guess a follow-up question was, couldn't these deficiencies be addressed by the independent evaluation panel? So I guess the panel that actually review the individual products going through SQIDEP. Sure,
but how? If there's no weighting or scoring system, how do you ensure consistency between one of the experts on the independent evaluation panel and another one? So moving through time, when it's got one technology and you have several reviewers, that's okay, they can have a consensus of views. But when you're moving through time at 6 or 12 months post with a different technology, with a different reviewer, when you don't meet the standard, what do? Does one reviewer give the whole study a big cross and you get a 0 outcome? Or they say, oh, look, not a big deal. We'll just take 1 or 2% off, 1 or 2, 5, 10, 5 or 10% difference in efficiency makes a huge, huge issue. So you need to get that consistency between reviewers across products over time. It's quite difficult to do that without some sort of weighting or scoring system. And then if you weren't happy with the result, you know, what is the grievance process around it? It needs to be well documented. There's a lot of, when you start thinking about it and going through, there's lots of little things that can make a big issue at the end of the day.
Cool. Just a reminder, you're welcome to put forward your questions. They're certainly coming through, but if you've got a burning question, feel free to chuck it at Michael. Now's the time to ask. Nilu Tara, hello Nilu from Brisbane City Council. She's asked, can you explain the importance of design flow versus maximum flow impact on the treatment reduction?
Yeah, look, maximum flow, what is it? Is that just the peak flow that you can run through your device when the water's flowing over the weirs and not actually getting any treatment? And treatable flow, because what we're really interested here with testing these devices is peak treatment flow rate. We want to know when we put water in one end of the device, goes through the whole treatment process and comes out, what's the difference between water quality in those two? Now to up that number, because those numbers are relatively low, people then start to talk about, well, maximum treatable flow rate. So they're saying, hey, the treatment flow going through the device plus some bypass as well. That's the peak flow we can get through the entire structure. Now, that might be the maximum treatment flow rate, but that's actually not 100% of that flow going through all that treatment process. There's a bit in bypass. So that's why it's important to differentiate the two.
Cool. Another question from Ainsley Kirk. Does SQIDEP give weighting to local versus international data?
No, there's two pathways as far as we're aware. Again, without a weighting system, it's really hard to tell what each reviewer would do. You know, it's a difficult one, but as far as we know, there's a body of evidence pathway which doesn't have to submit a QAPP, which can be Australian or international data. So there's that pathway, and there's the local field testing pathway, which obviously is in Australia. So, you know, I'm less concerned about testing, you know, sites, you know, North America, Europe versus Australia. I'm not too concerned about the differences there, because every site is different. You can have a site different in Brisbane, one side of Brisbane to the other. You know, in sites of Bloomberg, they're totally different. It's less about that. It's more about the build-up, wash-off of pollutants, and the species of those pollutants, especially in respect to nitrogen washing off your catchment. So it's not about having, hey, is Sydney different to Brisbane? Because a lot of these cartridge filters and things like that, we run at peak flow rates. They have an orifice disk, so hydrology, with a maximum contact time, so hydrology goes out the window as far as what flow rate they run at. But the key thing that changes is the magnitude of pollutants and the species of pollutants. That certainly affects your result. Sure, seasonal variations, temperate tropical climates will have an effect, but I tell you, and you look at the example, you test a site with 45% DIN, dissolved inorganic nitrogen, you compare that to a site with 15% DIN, don't care what it is, you're going to get different results. So the best way to look at it is just to say, look, there needs to be some minimum requirements for the pollutants washing off these catchments.
Yep. Thank you, Michael. Another question from Mel Brown. Mel, he asks, is Ocean Protect going to go through SQIDEP? And if not, why?
At this stage, no. And why? Because there's only about a few councils that have bought onto it. At the end of the day, I want to go through a national framework. I want to go through a process. But from our perspective, why would we pay a significant amount of money for each technology? Why would we pay that money if we're not guaranteed of any approval or outcome at the end of the day? You know, we can spend all that money. Doesn't get me an approval at a council that we need to have our devices specified for development applications. That council doesn't endorse it, well, then there's no point. So for us at the moment, until there's significant buy-in from councils, yeah, it's the cost. It's the cost of the field sampling to set up a site. That's how significant it is.
Cool. I've got a couple other questions. Yeah, I guess a similar question. Is SQIDEP really necessary if pretty much all other proprietors suggest it's okay as it is? Are we just trying to favour Ocean Protect by making it, I don't know, more stringent?
Look, we don't get me wrong. We've been field testing for quite some time. We've got a lot of data at Ocean Protect. If you know, and whoever in this situation currently SQIDEP the way it is, you know, if you've got a lot of data, you can get a great result. So commercially for us, it wouldn't be a bad thing to actually let SQIDEP go as it is. You saw the results of one of our sites. We cherry-picked the data. The results for TN look great, and our approvals would be great. So yeah, commercially for us, it actually would be advantageous to accept SQIDEP at the moment. But I have a real ethical and moral dilemma with that. I know where the loopholes are, and as soon as one person exploits them, then commercially we have to do the same to catch up. And that's not something that I really want to go towards. We just want a level playing field that's fair. We don't want it overly onerous. We just want it to be reasonable, to give you a good, satisfactory scientific outcome on your site. That's all we want.
Another question from Chris Beechaw. Is there a jurisdiction with a dissolved inorganic nitrogen requirement. So are there any other councils that actually do require a minimum DIN level?
Yeah, there's a few. Officially, unofficially, there's a couple in Sydney that are working towards it, and they want to see that in their catchments. Gold Coast in their protocol had this requirement, and that went through about 3 iterations, and they had that 40%. Now, I'm not advocating a certain percent, 25, 30%, 40%, thereabouts is a good enough number. We don't want to see 60% DIN or anything like that. So, something that's reasonable, because you will have sites that have low DIN, some sites that have high. So, to answer your question, Chris, yeah, there's a few councils that are doing it, and that's part of the issue and reason for talking today. We have council or regulators here in Sydney that want an overlay of information to cover that exact point. So they won't endorse SQIDEP in its current form, and they want us to show a level of dissolving organic nitrogen in the stormwater mix. So we can go and get an approval or go through them, go through SQIDEP or get an approval, but we still have to meet this additional criteria.
Very good. Another question from Remy Peterson. Why is Blacktown City Council recommended as a leader in critiquing SQUID technologies? What are they doing different to other councils?
Oh, look, they've been in this space a long time. They've got a fair few people involved. They have, a lot of capacity within that council. There's some really good operators there that we've been working with for a while. A really diverse sort of array of skills there. So, and look, they have the funding as well. They're sort of the first council we're looking at is really testing some of these devices. They're looking at spending a significant amount of money field testing bioretention systems, their own bioretention systems. So they're quite active in this space, a lot of people involved, a lot of funding. That's what makes them a relatively good council in this regard, doing a really good job, especially on that sort of development application side and water sensitive urban design. So, yeah.
Very good. Look, I promised I'd be done and dusted by, I think I said 1:45, 1:50, and we're pretty much bang on time. I just got one more question from Ainsley. How much, is in relation to, to the local versus international data, how much of Ocean Protect's data is local and how much of it is international? She says she comes across a lot of proprietors that only present international data and not so much Australian data.
Oh, look, we have a mix of both. We've got data here in Australia, we've got data from overseas. Just because the data's from overseas doesn't make it bad. And just because the data's from Australia doesn't make it any good either. It's less about the regional context for me, more about the quality of the study. That's really the sort of the key point there. But we've got a mix of both. And really you ask yourself, if we get a good quality study out of North America, and it measures all the pollutants that we want and meets protocols, well, then why shouldn't it be accepted? Converse to that, should we have a bad study in Australia and it doesn't meet the guidelines and be accepted just because it's from Australia? It's not a good outcome either. So it's really all about the quality of the data, quality of the study, that I think in this space is really important.
I reckon we might actually wrap up there. So just as a bit of a follow-up, I know Ocean Protect will be sending out a technical memorandum to all registered participants of this webinar, and basically explaining providing a little bit more detail in relation to what Michael has covered today. Michael's coming his head because honestly, most of the comments I'm getting through on the feed are actually glowing references to his hair. So look, it's hard to actually sift through the questions and the compliments, but I'm doing my best. But yeah, look, following on from this webinar, we're going to send, Michael's going to send out a technical memorandum outlining, the technical detail behind his sort of presentation today. We'll also be sending out a survey as well. And obviously you are welcome to contact Michael Wicks following today's presentation with any sort of follow-up questions you might have. I think his contact details are still on the screen. So look, without further ado, look, I just like to thank everyone who attended today. It was a really, really great turnout. I think we had, I think about 130 in attendance for most of it. And we had some great questions, but particularly, obviously, thank you very much for Michael for giving up his time and energy to provide his presentation today. And like I indicated before, this will be the first of a series of webinars put on by Ocean Protect, and I look forward to seeing you at the next ones. They'll be promoted via LinkedIn and email. But without further ado, thank you everyone for coming along today, and I wish you all the best for the rest of your day.